exercise 1B. Are there any problems doing exercise 1B? Of course, no problem, because you're now doing it, that is the problem. Yes. Any problems doing exercise 1B? Question 4, 5, 7, 9C. Okay, great. Then could you submit your homework to the front? Ada is not here today. The noun set. Oh, the symbol itself is called by Chpt. Yeah. Okay, today we're going to cover chapter 1.5. Alright. Then we will be done with this chapter. Let me give you the worksheet that I'll be using for today. So the exercise 1B quizzes are submitted, right? Okay, so today we're going to be looking at combining universal set, complement of a set, subset, intersection, union of set. So everything that we have actually learned, we're going to combine it all together. Okay, so we will first look at practice now 7. Question 1. Okay, so in question 1, we are given that the universal set refers to x, where x is a positive integer not more than 9, And then A is where X is a odd number, B is where X is a multiple of 3. Okay, so in part A, we want to list all the elements in the universal set A and in B, okay, in set notation. So could you just take 2 minutes, right, to list out all these elements? Okay. Are we done with listing the elements? So what is in the universal set? Again, what is the elements in the universal set? 1 to 9, okay? And then what about in set A? What do we have? Charmaine? 1, 3, 5, 7, 9. And then, what about in B? Teresa? 3, 6, and 9. Great. Okay. So then after that, in part B, we want to draw a Venn diagram to represent the universal set. Then A and also for B. Okay, so how will this Venn diagram actually look like for you? Dylan, what do you think? Tell me what to draw first. Rectangle, okay. And then this is the universal set. 2 circles, are they overlapping or one within another? Overlapping, okay. Alright, so you want to label this as A and B, okay. So what are the elements inside? Maybe on this side? 1, 5, and 7, overlapping, 3 and 9, and in B, 6, what about outside? 2, 4, 8, great. Okay, so this would be how our Venn diagram could look like. It is okay if you have your set B on the left and set A on the right, okay, so long as the elements are actually correctly placed, okay. So our main focus for today, alright, is more on looking at questions like C part I, okay, or C part 2. Okay, so how do we actually understand the notation and how do we go about listing out these elements? Okay, so in part I, we want to find out what are the elements inside A union B, and notice that there's brackets and complement. Okay, so it's a mixture of our set notation and algebra. Okay, so usually our understanding about algebra is that we do the things inside the brackets first, and inside the brackets itself is now A union B. So our understanding of A union B is that everything that is combining, okay, set A and set B itself, that will mean our elements 1, 5, 7, 3, 9, and 6. Agree? Okay, so our elements in A union B will be all this inside here. But then there is a complement outside. Okay, so complement is our understanding of reverse. Okay, the ones outside. Okay, outside of what? Outside of our A union B. Okay, so in actual fact, when we look at A union B complement, we are actually looking at 2, 4, and 8 as the elements of this set. Right? Are we clear? Any questions? Yeah? Now, part 2. Okay, we want to look at A intersect B prime. Okay, or rather A intersect B complement. So, as for what we understand, set A is our elements 1, 5, 7, 3, and 9, intersecting with B complement. So, where is B complement? B complement is the one outside. Okay, outside where? Outside the set B. Okay, so let's just do some shading. Later on, we will be doing more of shading. So, we see that we have our A over here, right? Okay, this is our set A. And then we want to intersect it with our B complement. So B complement, okay, maybe I choose a better color. So our B complement is entirely outside of B. Is orange a confusing color? Okay, I'll just read it. Okay, outside of B, and that includes, okay, this section itself where there is A. Okay, because our B is over here. Right? So now we're looking at the intersection between our A and also our B complement. So that means the red part and the green part. So where exactly is there an overlap? It is actually in this area only. Okay? This is just a rough working. When we do our shading, okay, it is not going to look like this. Okay, so our elements in our A intersect B prime is going to be 1, 5, and 7 only. Okay. Any questions? Okay. So in the exam, how would you want to go about doing the working? Okay. You notice that when I went about doing part 2, okay, I made use of the Venn diagram. Okay, but this Venn diagram is an answer to part B. I would suggest that leave that Venn diagram alone, draw another separate one for you to shade, okay, and identify the correct elements. Okay, then after that you can list it out so that you don't actually mess up the answer in B itself. If you show this as the answer to the examiners, I think it will be very troublesome, okay, for the examiners to give you any marks at all. Okay. Okay, so next we look at question 2, where we are looking at the universal set of all triangles that are possible. R is the set, okay, of right angle triangles only. I is the set where it is a triangle with exactly 2 equal sides. Okay, and then T, U, V, and W, they are triangles with different kind of dimensions. Okay. Could I erase just now the answer? Erase up. Okay, so what the question requires you to do is that in the Venn diagram that has been provided to you, they want you to put in the elements accordingly. Okay, so where do you put these triangles? Okay, let's start with triangle T first. 3, 4, and 5. It is definitely a triangle. All these are triangles, so it's definitely going to fall within our universal set. Okay. The question will be, is this going to be a right angle triangle, or is it going to fall under two equal sides? Or is it going to fall under both, or is it not going to fall into any of it? Joseph said that it's a right angle triangle. Do you agree, Kejiang? What tells you that it's a right angle triangle?
We use Pythagoras theorem.
Okay, so we can use Pythagoras theorem. Okay, we would be very familiar with this Pythagorean triplet by now, 3, 4, and 5. Okay, it actually forms for you a right angle triangle where 3 cm, 4 cm, and 5 cm is the hypotenuse. Okay, but I just want to emphasize to you that this is the only, I'm not saying this is only, but this is one of the few Pythagorean triplets, okay, that actually fall in consecutive order. If I give you 7, 8, 9, that is not going to be to form for you a right angle triangle, okay? So 3, 4, and 5 is one of this, in fact the smallest, okay, right angle triangle that you get. Okay, so T is actually a right angle triangle. That means it's going to fall under R. Okay, there are clearly no two equal sides, so there shouldn't be any overlap. So you will put T over here. Okay. Now what about U? U is a right angle triangle as well as a triangle with exactly two equal sides. Why would you say that it's a triangle with two equal sides? Nicole? Two of the angles is 45 degrees. Okay, so with using our base angles of isosceles triangle property, we can tell that this is going to be an isosceles triangle. So then after that, we also clearly see that there's a 90 degrees. That's why it will be a right angle triangle, and U will be actually here. Okay. Next, we look at B, triangle B. So triangle with 5 cm, 8 cm, 8 cm. Okay. What kind of triangle would it be then? Would it be a right angle triangle? And so what do you think? Would it be a right angle triangle? Sorry? It's a B. It's not a right angle triangle. Okay. So how do you know that it is not a right angle triangle? Because there are two equal sides. And then? Sorry. Okay, Pythagoras theorem will work. Okay, so answer says that because there are two equal sides, and then Pythagoras theorem will work. So let me just write that down first. Okay, two equal sides and Pythagoras theorem. Okay. I just want to point out to you that having two equal sides doesn't help us to conclude that it cannot be a right angle triangle. Because we can see that in triangle U itself, there will be two equal sides, and in fact it is going to be a right angle triangle. Okay, so there can be isosceles right angle triangle. Okay, so using two equal sides to justify that V is not going to be a right angle triangle is not going to be a sufficient condition. Okay, so what we can do to actually prove that it's not a right angle triangle is always go back to our Pythagoras theorem. Okay, so in this case, if we use Pythagoras theorem, our 8 squared will not be equals to 5 squared plus 8 squared. Okay, so that's why V is not a right angle triangle, cannot fall under R. And then we also see that there's two equal sides, so therefore V must fall in the set I. Okay. And then finally for the triangle W, okay, where we have triangle with 5 cm, 5 cm, and an included angle of 60 degrees. Okay, so then how will we go about concluding this? Where will it be? Sorry? Two equal sides. Okay, so yeah, so it will be a triangle with two equal sides, right? Okay, so therefore W would be falling in the set I. Yeah, 容易 something. Yeah. Oh, okay, you're right. Hang on now. 60, 5. Yes, you are right. Okay. Carissa pointed out something, right? Okay, so Carissa says that this is going to be an equilateral triangle. So why? Because we have 5 cm, 5 cm, and then it says an included angle of 60 degrees. But because of our base angles of isosceles triangle, we know that these two angles will have to be equal. Okay, so what's the sum of these two angles going to be? It will be 180 minus 60, right? So that's 120 degrees. If you divide it by 2, then it will be 60 degrees, 60 degrees. Okay, and therefore, if we see that 60, 60, 60 is going to be an equilateral triangle, and therefore x must be three-sided. Okay, there is exactly 3 equal sides. So therefore, it doesn't fall under set I, and you will have to fall outside here. Okay. Right. Any questions? If no questions, I want us to refer to our worksheet now. We have just given to you. Set up the visualizer. How do I switch this on? Okay, so we're going to do some shading of our Venn diagrams. Okay, so looking at practice now 8, right? Okay, we want to identify and shade the following region or separate Venn diagrams. So just now I introduced to you how to shade already. When it comes to shading, you don't need to do your like artistic kind of shading where you give me light to dark and all that. Okay, you can just use lines and draw across. Okay, that's perfectly fine as well. But I want to point out no highlighters, okay, because exam doesn't allow you to use highlighters on the question paper. Okay, so just use a pencil to shade. I do not recommend using a pen to shade because in the exam there's only going to be that one Venn diagram. If you use a pen, then that's it. Okay, somewhere you cannot use your correction fluid or your correction tape, right? So don't ruin the diagram. Therefore, use a pencil. Okay, so in part I, let's just do the first few questions together. Is it too bright? And the people at the back see? Hannah? Okay, so in part I, we have x prime union y. Okay, so x prime itself, sometimes what you want to do is maybe you want to do a sketch first. Okay, so that the one that you shade in the end is going to be the final one. Okay, but of course, after you practice for a very long time, you may be able to catch the final shading easily. Okay, so x prime is actually the ones outside. Okay, can you see this? Let's see, or do you need me to draw it darker? Let me erase this. Okay, so you can do a sketch first. X and Y. Okay, so x prime is the one outside of the circle X. That will be this part here. Okay, so you can shade the way that I shade in the final one, but we are just doing a sketch first. Then after that, union with y. Okay, y itself refers to this. Okay, since we are looking at the union, that means all that has been shaded will be answering this question. Therefore, okay, what should be the answer? Just for your benefit from your seat, okay, I've used a highlighter. We should be shading, okay, everything in y and everything outside of x. Okay, it should look somewhat like that. So you can shade just with lines like this, also fine. Okay, in fact, I would recommend doing this. No need to be so finely spaced out. Okay, as long as it is a clear diagram. Any questions? Next, in part 2, okay, we want x complement intersect y. So, drawing the diagram again. As a sketch, x complement refers to the one outside of x. Okay, and intersecting with y. Y was this one. So since we are looking at the intersection from our sketch itself, we can see that the intersection where there is both the black and the gray markings would be this part here. Okay, so therefore onto our final diagram, okay, we will be having a shape just this. Any questions? Then after that, in part 3, we want to shade x union y bracket complement. Okay, so how would this look like? Okay, x union y means that it is actually the two circles itself, but we want the complement. So complements means the one outside of what I have already shaded. So therefore, in my final answer, it should look like this. Okay? If you understand what I'm doing already, I'll give you about 2 to 3 minutes, okay, to actually work on part 4, 5, and 6. Okay. Give you 2 minutes first. Could you do the shading of this? that some of you need more time. Give me another 2 minutes. Okay, if you have questions, you can please raise your hand and ask me. Yeah, just do the first one. Are we done? Okay. Shall we go through our answers? I think some of you catch it quite fast. You probably already learned it before. Okay. So let's look at part 4. We have x complement union y complement. So you may want to draw a sketch of it first. Okay. So x complement will refer to whatever that is outside of x. And then after that, y complement will refer to anything that's outside of y. So y is over here. Okay, so that will mean that I am looking at this part. Okay, then now I want x complement union y complement. That means everything that has been shaded at least once, okay, will be our answer. That means that the only blank that we should be seeing is this intersection, this overlap over here. Okay, and therefore our final answer should look something like this. Okay, so there should be a clear blank over here. Alright, next one, part 5. Okay, we want x x complement intersect with y complement. So just now we have shaded already. For the blue ones that are shaded, that is our x complement. Red one that are shaded is the y complement. We are looking at the intersection. That means that we want the ones where they are shaded at least twice. Okay, so therefore it is entirely outside of the circles, and our answer should then look like this. Okay? And finally, for our part 6, we are looking at x intersect y complement, then we complement again. So if you want to go through that figure of looking at what's inside the brackets first, that is your x intersect y complement. So x refers to this one. Y complement, okay, refers to outside of y. Okay, so outside of y Okay, and we're looking at the intersection of x intersect y complement. That means that we are actually focusing on this part. Okay, this is just a sketch, so I'm really anyhow. Okay, this part over here. Okay, but then we want complement again. So that means it's anything outside of this green mass over here. Okay, so therefore my final answer, okay, should actually be like this. Leaving the x portion here empty. Okay. So if we look at the overall of our practice now 8, okay, there is some conclusion that we can draw. I know that some of you already have the conclusion. That's good. Okay, we notice that there are some of the diagrams over here. They actually mean the same thing. Okay, so I want you to be able to notice that our part 3 and our part 5, okay, they actually look exactly the same. Right? So what we see over here is that x union y complement is equals to x complement y complement. Okay, our diagram 3 and our diagram 5 is the same. Okay, another tool that we can observe to be the same is that this one in part I is the same as ours in part 6. They actually are the same. So we can say that the set x complement union y is equals to bracket x intersect y complement y complement. Okay, so this is our part 3, our part 5, part I, and part 6. So what do we observe over here? Okay, x union y complement with the brackets and x prime intersect y prime complement. Okay, so we can see some algebraic application that seems to be possible. Meaning to say that I can bring in the complement sign. Okay, so I bring in the complement sign, so not expanding lah. Okay, but it isn't exactly our usual algebraic extension. We can bring the complement sign into our x. Let me zoom in to my handwriting here. Okay. We can bring in the complement sign into the x. We also can bring in the complement sign into the y. That's why I get x complement, y complement. But my complement sign must also influence the union over here, okay, such that my union change into intersection. It's just like how we usually see, for example, in our algebraic ways, okay, like for example, our negative a plus b. If we bring out negative, our plus will change into minus. So think of it that way. So our union will change into our intersect. Okay, so that's why they are actually equal. So with that in mind, okay, if we check how it is applying for this one, okay, for the one on the right, complement sign goes in, okay, so x complement, we get it here, y complement complement. Okay, so it's like, you know, you play your Uno, you do reverse and reverse again, then go back to original point. You know how to play Uno, right? So it works that way. So y complement complement, go back to original starting point y. Okay, then intersect complement become union. Right? So sometimes, especially when we have brackets and we need to do the shading, it can be very confusing, okay, to actually do the shading itself. Because if you notice how I did this one, okay, I had to go through a few steps over here. It would have been easier, okay, if you actually simplified this set notation. Okay, if you simplify this set notation into this, then it would have been easier to work out. You understand what I'm saying? Okay, so that is one trick that you could actually do. But of course, always check your answer now. Okay, always check your answer. Any questions? No, yeah? Okay, no questions, then let's move on to our exercise 1C question 14. Okay, I want you to do this entire question, all 8 of it, on your own now. I'll give you about 5 minutes. Okay, now that you have learned the trick, I'm sure it will be slightly easier to work things out. Okay, are we done? Do you need more time? No? Okay. I hope you enjoy this segment of the Venn diagram. I think it's the most fun activity. Huh? Isn't easy stuff fun to do? No? Huh? How is math fun for? What? You want more difficult stuff? That's very good. Okay, let's check our answers, okay? So A union B prime, okay, so that means the entire circle A, okay, with the outside of B prime union, that means it's together. So your answer should actually be including the overlap part, okay, and by it outside of E. Okay. Then after that, in part 2, we are looking at A itself intersecting with the outside of B prime. So the outside of B prime would mean that, okay, this area is included, and then after intersecting with A, so this will be the answer. Okay. Then for A union B bracket prime, like I mentioned, okay, how could we simplify this notation? What would that give us? Chloe, what do you think? How could we simplify this notation of A union B bracket prime? A prime union, is it? Okay, and then A prime union B prime. You sure? Joshua, you agree? A prime union B prime is a simplification of this notation. Then what should it be? It should be intersect. Okay, so it should have been A prime intersect B prime. Okay, think of it like your minus and plus. Minus and plus will be opposites of each other. So that's why you must flip the sign. Okay, so A prime intersect B prime. So A prime is the one outside. Then after that, B prime is also the one outside. So you want to entirely be shading the ones outside. So it really depends on the question itself. You may find that it is easier to work with this, but okay, for myself, I will find that it might be easier to work with this because looking at A union B means the two circles. Complement itself is just outside. So it may be easier to think this way sometimes as compared to think about this. Because there's a lot of complement going on. Okay, so you need to think of it things outside, and then after intersect. So it might not be easier to arrive at this conclusion very quickly with this notation. But of course it depends on yourself as well. Okay, I don't want to limit your habits. Okay. Then next, part 4, A intersect B prime. Okay, so like I mentioned earlier, it might be easier to work with this notation. A intersect B will just be this overlap. Okay, since you're looking at prime itself, that means the complement of this overlap, that will refer to everything outside of the overlap. Okay, so you see that I could arrive at this fairly quickly as compared to if I wanted to simplify it into A prime union B prime. Then I will have to think about outside of the circle A and outside of circle B. Then after I look at the union, that might not be that easy to arrive, or rather, it might not be that quick. Okay. Next, for part 5, okay, we are looking at A prime union B prime. So therefore, it would have to look like your answer in part 4. Okay, and our A prime intersect B prime, we agreed earlier that it was actually the same as in part 3. Okay. Then our A prime union B bracket prime. Okay, so this one, you may want to consider simplifying the notation. That will be A intersect B prime. So A itself is this entire circle intersecting with the outside of B. That will mean that this is the conclusion, which is the same as our answer in part 2. And then finally, simplifying this notation will give us A prime intersect B. So A prime is the one outside of A. Intersecting with B itself will tell us that this is the answer. Okay. At this point, what I have been what we have been doing is that given the notation, we do the shading. There could be questions that give you the shading, ask you to create the notation. Okay. I think that will be slightly more challenging. Right? Given the shading and then create notation, we will practice it more. Yes, there will be a wider variety of answers. Okay, but of course, when it comes to the notation to derive, right, sometimes it can be rather long, right? It can be very long notation itself. Okay, but usually it wouldn't be that long. So it depends. I'll find out those questions and then after that, show it to you. Okay, currently your textbook doesn't have those questions. Okay, so yeah, I'm only there 5 minutes. I want you to go back home, okay, to do question 15 and question 16 in this worksheet. Alright, then tomorrow, so that will be a homework. Okay, I believe you could actually finish it over your lunch as possible. Okay, so shouldn't take up too much time. Right, tomorrow we will check through our answers. Okay, for that. Then after I have 2 more questions for 1.5 and we're done. Then we will move on into chapter 2. Okay, we'll end here. Thank you everyone.